Okay, hello. I'm going to be doing the questions for a Calculus 1 exam. Now, for the first question, For the first question, 1a, it asks, if f of x is equal to cotangent x square root of 1 minus x squared plus sine pi x over 2, then what is f of 0? So basically, if I write the problem out, okay, so that's the problem. Now it's asking for f of 0. So all you have to do is just plug in 0 into every x. About that, plus sine 0 over 2. So here we can start doing this one by one. So 0 squared is 0, 1 minus 0 is 1. The square root of 1 is 1, and 1 times 0 is 0. So obviously, this would stay as cotangent 0. And then for this, the sine, pi times 0 is 0, and 0 divided by 2 is 0. So this would also be sine 0. Now, cotangent is also the same thing as 1 over tangent. So we put a 0 there. And then sine of 0, if you know the unit circle, that would just be 0. Now, 1 over tan 0 would also be the same thing as 1 over sine 0 over cosine 0, which, if you go further, sine 0 is 0, but cosine 0 is 1. So 0 over 1 would equal 0, so it would be 1 over 0. But 1 over 0 is not an answer, so it's undefined. You see that? So therefore, undefined plus 0, that would just be does not exist for 1a. That's good. Okay, now 1b is the inverse function of log base 10 of x. So 1b is asking for the inverse. So for this one, you would have to write it out as a function. So log base 10 of x equals y. Then you would switch the x and the y. So log base 10 y equals x. Now here, if you know the rules to switching from logarithmic form to exponential form, which is something like this, and that would go to, so log base b of n equals a, going to b to the a equals n. So you do the same thing here. So that would just mean that 10x equals y. So therefore, the inverse would just be 10x. It's good. Now the next one is 1c, which asks, true or false, you can always divide by e to the x. Now that answer is true because e to the x can never be 0. Now that just basically means like whenever you divide by 0, the function is undefined or does not exist, or infinity, some kind of thing like that. So if e of the x can never be 0, that means you can always divide by it. Now, 1d, the limit as x approaches 2 and 3 minus x over 3 minus x absolute value. So I wrote out the problem right here. So basically for this, so for the absolute value 3 minus x, it's basically the same thing as writing it like this, 3 minus x, and then negative 3 minus x. Now since the limit is asking where it's going to 2, this one would be greater than 2, and this one would be less than 2. So basically, you just have to do the top and bottom. So 3 minus x over 3 minus x. Limit as x approaches 2. So that would just equal 1. If you plug in 2 to each x, it'll just be 1 over 1 equals 1. Then you have to do the same thing with this one. Limit x approaches 2, 3 minus x over negative 3 minus x, which would basically, if you plug in 2 again to each one, be 1 over negative 1, which equals negative 1. So basically, since the left-hand limit and right-hand limit, or these two do not equal, the limit as x approaches 2 for this function does not exist. Good. Now 1e. Now it says for that graph of the function below, find the following. So for 1ei, it's saying the limit as x approaches infinity. That would just be as x goes to infinity, which goes this way. The limit is basically just 2. So for that one, I just write it's 2. And for I is asking for the limit as x approaches 2 from the left. Now here is 2, and from the left it would be this way. It would go down to negative infinity. Now for this one, x as the limit approaches x to 2, 2 is right here, but it's not from the left, it's from just the limit. So since the left-hand limit, that one goes to infinity, the right hand goes to positive infinity, and this one goes to negative. But since they're different, they do not equal. The limit does not exist. So it does not exist. last part asks for the vertical and horizontal asymptotes of this. So for the vertical asymptotes, you can see that there's one, because the graph is like discontinuous here. You see there's one at x equals 0, and there's also another one at x equals 2. So x equals 0 equals 2. And for the horizontal one, there's clearly an asymptote right here at y equals 1. Oops. And there also seems to be one at y equals around 0.5 also. And the function can have no more than 2 horizontal asymptotes, so that is all 0.5. So that is the solutions to all of number 1.